All right, there's a lot going on in this first problem. What's the value of A? That's an angle outside of a circle. It's an angle, so it's going to be one of the angle formulas. In this case, it's 1/2 the difference of the two arcs it makes. One of those arcs is 135, and the other is not labeled currently. It's this blue arc. So I need to find this blue arc. Well, I know all the other arcs, so I could just do 360 minus those. And then I get 51, which is then what I'm missing here. And then when you math that out, you get 42. So A is 42. What's the value of B? B is inside the circle right here, but it's not in the center or on the edge. And so it's 1/2 the sum of the two arcs. And in this case, it's 66 is the one arc, and then the other one is that blue one I just found. So 58.5, the sum of those was 117. So both of those are just know the formulas. Yeah. To the nearest tenth, what is C? Okay, so now we have C is tangent line. Oh, so this is the outside the circle. So it's going to be the outside part times the whole thing equals the outside times the whole thing. But C in this problem is a tangent, and so it is the outside and the whole thing. So it ends up being C squared is the outside part, 13, times the whole thing, which is not 13 or 14, but 13 plus 14, where those are the appropriately highlighted 13 and 14. So this all equals 351, and so then I need to do square root of 351. I guess let's do it here. And it's said to the nearest tenth, so I'll just round it 18.7. So that's one where I'm missing a segment, and so I do whole times parts equals whole times parts kind of thing. Value of D, this one is easier. This is just whole times, this is a segment inside, and so then I just do 14 times 13 equals 14 times D. And again, these are, let's see, the way I did it, this is that 14, and this is the 13, and then that other 14 is the one I haven't highlighted yet, and the D. And so, oh, well, D must be 13, because 14 times 13 equals 14 times D. D must be 13. Okay, this next one is kind of lumped with these, but it's a totally separate problem. AC and DE intersect at point R and Q. Why don't I just draw that real quick? A key with drawing it is it's called circle Q. That means the center is Q. But these are intersecting at some other point. So I just need two lines that intersect, and we'll call that R. And this is not drawn to scale at all, but AC, DE. So I just need an AC on one side, a DE on the other, and then I'll just label stuff. So AR is 6, RC is 7, definitely not drawn to scale, but that's okay. And then this RE is my X. And so it just becomes 6 times 7 is 3 times what? I could make them match. Yeah, whatever. I'll just do the math like this. 42 is 3 times what? So X must be 14. Or RE must be 14. And that's my final answer. All right, the next series, all dealing with another kind of complicated problem here. But inch by inch, it's a cinch. So X and, let's see, Z are both segments. So those are both the part whole thing. Part equals part. So 8 times X, one part times the other, equals one part times the other, because 4, 8, 12, and X right here are all in the circle. And so 48 equals 8x, x is 6. So x is 6. Let me separate. Okay. I'm going to skip y for a sec. Z is the same rule we just did. The outside times the whole, because it's z squared because it's a tangent, equals the outside, which is the little 2, times the whole, which is 16, or 12 plus 4, right here, 12 and 4. And so, yeah. And so z squared is 2 times 16, so z squared is 32, so z is the square root of 32, which is 4 root 2, if you want to be fancy, because 16 goes into 32 twice. And you can take out the root 16 as a 4. But anyway, so there's z, same rule as before. The outside times the whole equals the outside times the whole. And when the outside and whole are the same because of the tangent, you can just square the z. Now going back to y is an angle. And so y is where? It's not in the center, so it would equal the arc. It's not on the arc, so that it equals half the arc. It's in the middle somewhere else, and so it equals half the sum of some arcs. So which arcs does it make? It makes 80 and 100. And so, so it's half of 180. It's a right angle. So, oops, I'm writing in a highlighter. 180, so 90 is my answer for y. Okay, next, x is where? It's in the center. So x equals that arc. Oh, but how do I know that arc? That's interesting. 46 degrees equals what? That arc? No. Okay, so let's break it down. 46 is 46 equals half the difference of these two arcs. Okay, so which two arcs? That would be, let's call them y and w. It would be y minus w. Now this doesn't seem helpful. Oh, and then x is w, right? So I could now put an x in here, because x and w are the same because x is a central angle here. So is that helpful? Well, sure. It just, I don't know, maybe it doesn't seem like it at first, but inch by inch, 46 doubled is 92, is y minus x. But now I could figure out that if y minus x is 92, how else are they related? Well, y and x add up to 360, so I could say 92 equals 360 minus x, which gets me a weird expression, but it's just algebra. Minus x is minus 2x, and then I can just move the 360 over, the 2x over. I'm going to move my work up here. So then it's just a matter of algebra. So 92 minus 360 is equal to negative 2x. 92 minus 360 is negative 268 equals negative 2x. So x is half of 268, and the negative cancels, so x is 134. Kind of tricky. I like that one. This one's a bit easier. Number whatever, I didn't number these. T is on the circle, so it's simply half of the arc, and I know it's arc, 210, so T, or 220, so T is 210. S, then, is simply 360 minus that. Or, sorry, 360 minus 220. Or, I could do 180 minus 210. That would give me that this is 70, which then that arc would be 140, or this is 140. Okay. The next one, a cool one, 40, that means this is 80. And then Z is 360 minus 80? What? No, what's this other side? Oh, this is a center right here. And so this whole arc is 180, so I could just do 180 minus 80. because z is part of a half a circle, or I could do 360 minus 180 minus 8. So z is 100 degrees. Okay. This one just standard. 6x is 8 times 15. Part times part equals part times part. 8 times 15 divided by 6 is 20. And then this one, not 10 times 6 equals 8 times x. Because this one is outside, so this is 10 times the whole thing, 10 plus 6, equals 8 times the whole thing, which is a little bit tricky, x plus 8. But this is simply an algebraic expression, which I'm sure you could solve. You actually have a couple options. You could distribute that 8, or you could just divide it over. Either way, I think I'm going to divide it over just because that is a little bit trickier and nicer. So if I divide this by 8, the 16 becomes a 2, and then this is just 20, and so x is just 12. That's a little easier algebra, but you could also distribute and get the x by itself. All right. What's the perimeter of GHI? This is simply the whole, if you have a tangent to a circle, it's always like all of these are congruent. And so I could just copy all of these down here, and then I could just add all those up. So this is, let's see, 4, 12, 10. 4, 12, and 10 is 26. So 26 inches, done. X, Y, and Z. Okay, got a lot going on. Let's start with X. How about? Okay, so X is on the circle. So X is half of its arc. So X is half of that arc. Well, that arc is 86 and 64, which is what, 150. So X is 75, if I didn't make a mistake there. Once I get 75, I could now basically get everything, right? Also, right away, even without that, I could have got this arc is double this angle. So this arc is 116. And then I could get that other arc if I needed it, which I don't actually, so I could just be done. So y is 116. Which I didn't, you need x actually, and then z is on the circle, so z is simply half of 116 because it makes the arc, it makes the same blue arc. So z is the same as m, there is that 58. Because 58, this angle is making the same arc as this angle. So this angle and this angle must be the same. So I could have done that without even finding the 116. So that's going back to inscribed angles are half of the arcs they make. This is from Education Perfect. What is theta? This is much easier than some of you made it back when we did Education Perfect. 45 degrees is making this arc. I could say this arc is then 90. Well, check this out. This angle makes that arc. So this is also 45, and so this is just 180 minus 45. Should probably put the answer. Okay, over here we have a couple things. We have x being in the circle, so x is half the sum of two arcs. We have y being an arc. I can see that 36 is going to be helpful here. I also see a center, so diameter. So I do know that this, let me get a different color, this whole thing here, the purple, is 180 because it's a diameter. That would mean that this littler one right here, this is 180 minus 70 minus 30, so this is 80, if that's helpful. So let's see. Well, actually, yeah, that's one of these. That's this 80 or the other. And then the other half of x, so to speak, x is also making up this arc here because it goes, x makes these two lines make that green arc, which is a whole half the circle. So this is 180 plus 80. So what's halfway between 180 and 80 would be what, 135? No, 130. Okay, so am I writing the right color? So x is 130. Now, y is going to be involve the 36, so I would do 36 is half the difference in its arcs. The far arc from 36 is this arc over here, which is the purple arc, which is, I almost wrote 360, which is 180. It's the purple arc. And then the nearer arc is y. And so that should help me solve for y. So again, probably easier to clear the half rather than distribute it. 180 minus y. You could also distribute the half. And then I just do 180 minus 72, basically. And then the negatives will cancel, so 108. All right, explain why opposite angles are always supplementary. Opposite angles in a quadrilateral inscribed in a circle. So I need a circle, and I need a four-sided figure in here. Why would opposite angles like x and y always add up to 180? Be supplementary? Oh, because you could cut this in half, and it will always go through, actually it doesn't matter if it goes through the center, because now I'd say, oh, so y is half of this arc. So y is half of that. Let's call that w. That's the arc. And x is half of this, which we can call, I guess, z. And then it should be, hopefully, a nice series of things where we'd say y is half w, x is half z, half z, and it's very clear that w and z make up the whole thing. And so now if I just replace these, I'd say that 2y plus 2x, because x is a half z, so z is double x, is 360, so x plus y is 180, which therefore is supplementary. So there was kind of like a little proof of that. And then lastly, I'm not going to do this, but just make sure part of your test is going to be to just explain the difference between these vocab words, so you can, hopefully you know how to do that just fine.